Hello everyone, welcome to my channel. So today we are going to do second question for the try in this playlist of tries. So let us read this question and then let's get started. So here we are basically given with prefix tree, that is a trie data structure used to efficiently store and retrieve keys in a data set of string. There are various applications of this. Find this we read in the previous question also. So now we are required to implement the trie class, and in this trie class basically, so this trie class insert same as before, count word equals to string. This is new thing which we need to implement. Return the number of instances of the string word in the trie. Means so far whatever number of words are being already inserted, that we need to return. Count words starting with, again for the prefixes whatever would be existing, that we need to return the count of that. And then void erase, and we are required to erase when this particular function is being called, we need to erase that particular word from trie. Means basically only that instant, not all words but only that word, means that count only. So that is required to be implemented here. So now if you have not watched the previous video which I had created on trie, then please do watch it. That is the basic level, so that you can easily do this particular question, because this had just the modification of the count and erase, else each and everything is same as before. So without any further ado, let's get started with the coding. Yeah, make sure that you have watched the previous one, else you won't be able to, like, even by yourself also you won't be able to code it. So just make sure you have watched. Now here, what data structure we are required to use? So here we are just storing these, right, and the counts are there. We can take a simple different variable also which will store the count for that particular word, and obviously a bool variable, because we require to check if that particular is a word or a prefix. So that's why we will be taking a bool variable. First we will be taking a vector whose data type is trie star, and we will name it as child. Then we will be taking int count, which will be basically counting the occurrence or instances of that particular word which is being inserted earlier or not, or something like that. So that would be the thing. And now the next thing which is there, bool variable, that is it ends with. So that would be the thing. Now these three are done. Now next thing which is required is we need to initialize them. So it will be having 26 characters null, and then we have count which is 0 at the start. Then we have basically our boolean ends with, which need to be false at the starting. Now our next task which is there to implement the trie class, the first thing which would be there is to insert. So for inserting purpose, what we are required to do is again the same thing which we were doing earlier, so that only we will be doing here also. So for the purpose of insertion, the first thing we need object of that class equals to this. So this is the object and also initialized. Now the next thing, we have the word and we are required to take each and every character from the same. So now we have taken that. Now we need to start inserting. First we need to check if that particular already exists or not. If it doesn't exist, then we need to create a new node for the same. And here, as it doesn't exist, that is the condition which we have put here. So in that context, what we are required to do is we need to create a new node, new trie, calling the default constructor. And then if it already existed or already the node has been created, then we will be moving ahead. And this index value is int index equals to c minus a. Now this is a thing. Now the thing would be ends with equals to true, and this is basically whatever current value which is there, for that we are, means for that particular node we are making as true. And another thing is we have another variable count, and we need to increment that count for that particular ending word. That is the thing. So now if you see, like, we could have taken unordered map also for this particular purpose, but we have not, because this is much more simpler than taking an unordered map, because we have an object which is pointing to that particular node, and whatever things could be taken, that we can take, rather than just creating an unordered map and having everything there. So that's the thing. Now after insertion, we have that count words equal to. This is more like searching that whole word. So if you want to copy paste, you can copy paste also. Else the thing is like, fine, let us implement it again. Try star current equals to this. The initial thing, creating the object. Now our object is created. Now whatever word is being given, we need to check for each character in that word, and need to check that if that exists or not. So now if not current child of index, then we will be returning false. And here basically it is required integer value, not true false, right? So that's why we will be returning here. Have they asked to return -1 something? If not, fine, we'll just return 0, that it doesn't exist. Else we will be moving forward. Current equals to what I mean, current index, current equals to this, and our index which is there, int index equals to c minus a. And at the end here we will be returning the current count, means whatever count of that particular word would be, that we will be returning. And now the next thing, starting with, in this again the same thing would, which we are doing here, that would be there. But here one thing is there, that current count which is there, we can't just return current count, we need to do something else instead of that, and that we need to think that how we can do that. So that is the thing. So for that purpose, if we return current count, that would be related to each and every word which is there, right? But this is basically a prefix, right? So for that prefix, what we can do, like, we can have something where it's about, like, with each word it is related, means each character it is related, means while we are inserting, at that point we can increment that, like that we can do. So because of that thing only, now what we are required to do is, rather than this bool ends with, we can have something like this, current starts with, and that we will increment. So here, and it will be at the starting 0, starts with, fine, we are incrementing that. Here anyhow not required, but here we will be returning starts with, so that, because anyhow we are here searching just for the prefix, right? So for prefix purpose, the starts with variable which is there, that would be with each and every character, and because of that thing, for the prefix part, it ends at any particular character just before that whole word ends, right? So because of that thing, we have this particular variable which will be there for each and every node, and because of whatever count which would be there for that particular character, it will just return that. So that's the thing. Now this was for this particular. Now comes the part for erasing the word. So for the purpose of erasing the word simply here refers to that it has been emptied from that particular, or better we can say that the count which is there starts with and ends with both counts are 0. That is what we refer to here with the erase part. So that only we will be doing. We will be, rather than incrementing those count, we will just decrement it. That is what we will do. So now here we will check for char c in the word which is there, and then we need to see this equals to c minus a. Now here we will be just moving ahead. We won't be even checking that if it really exists or not, because anyhow if it doesn't exist it will just move out only. But let us see. Although it is a good practice, if it doesn't exist, that also we can put actually. If it doesn't exist, then we'll just return out of that. That is what we can do. Means why we want to access something which even doesn't exist, right? So it's better. So now let us run this code and check for if there are any compilation stuff. Okay, yes, it starts with okay, fine. This test case has been passed, and if I'll submit, that will also pass. Now comes the part for the time complexity and space complexity. Again, it is basically dependent upon the length. So all are linear space complexity only, and even the time complexity. So that's why the overall time complexity and space complexity which is there completely dependent upon the word which we are basically inserting, searching and checking for the prefix. Even for the erase part also, it completely depends upon the length. So overall time complexity is linear, space complexity is also that is again dependent upon number of words which are there. So that space complexity is completely dependent on 26 raised to power number of words which are there, 26 raised to power n. So this was all for this particular question. If you have any doubt, you could comment that down. And I hope this particular video was useful for you all. And make sure you are following the series one step by step rather than jumping over any random questions in this particular series, because I'm creating these videos just as step by step to whatever was being created in the previous one. So make sure you are following them religiously step by step only. So this was all. And if you really like this, make sure you subscribe, share this among your friends, and also like and whatever comment you want to give over this video. So this was all. Thank you.